Hello everyone, my name is Jiang, and I am one of the authors of API Miner Detecting API Misuses via Automatically Mining API Path Patterns. Here's our author list and contact information. Our affiliation is the Institute of Software, Chinese Academy of Sciences. First, let me introduce the background. Nowadays, it is common practice for programmers to use APIs to realize specific functions without understanding the details of the internal working mechanism, which indicates the API patterns. However, violating API patterns will cause API misuses and can have profound security implications. A well-known example is the pattern of kmalloc class APIs: check allocation size, kmalloc, check return pointer, user pointer, and free. A removed stack overflow is expected if a function misses the check allocation size. Besides, if free is missed, it will cause a memory leak. The critical challenge in detecting API misuses is to obtain the corresponding API patterns. Existing researchers who extract API patterns can be broadly classified into three categories. The first category focuses on extracting API patterns from the source code. Most of them manually provide pattern templates as prerequisites and try to discover in what context the APIs should be used as templates. However, their templates require prior knowledge of the software and limit their extraction scope. The second category generates test cases to execute the software. It monitors dynamic chasing to mine the frequent sequences of APIs as API patterns. Nevertheless, generating test cases requires much manual effort. Moreover, because of the low coverage rate, it is a challenge for the work to gain complete API patterns. The third category extracts patterns from the documentation using NLP technologies. Unfortunately, most API patterns are too tedious for programmers to document and are implicit and hidden in the source code. Unlike the first category, our goal is to discover the probable correct usage of the APIs. Our critical insight is that API patterns usually consist of API data-related operations and are commonplace in the source code. Let me motivate our framework by a misuse of exec2gifs in the Linux kernel. The pattern and misuse of exec2gifs are shown in the upper and the lower figures respectively. The exec2gifs can convert microseconds into GIFs. The calculated equation is as the arrow points to. It can be found that when microseconds is not limited, an integer overflow error may occur. 146 out of 147 usages of exec2gifs follow the pattern. These are the control flow graphs. The check in the red circle is to avoid integer overflow. The check is data related to exec2gifs. However, we can build control flow graphs consisting of operations data related to exec2gifs from the 147 usages. The maximum frequent subgraphs are the patterns and can be used to detect the misuse. Thus, we present API Miner, who uses the frequent subgraph mining technique to extract the patterns from the source code automatically. Now, let's talk about how our system is designed. The high-level idea is to employ a frequent subgraph mining technique to infer API path patterns. This is the overview of our system. It starts from the source code and uses the data flow analysis to generate the API path. Then API Miner employs topologization and completion. After that, it builds index matrices and uses a frequent subgraph mining algorithm based on the a priori to extract the API path patterns efficiently. Finally, API Miner uses a binary discriminant to match the subgraphs and rank the violations to find probable API misuses. API paths are the control flow graphs consisting of API's data-related operations. Specifically, API Miner first uses the Clang compiler to convert the source code into a control flow graph. Then API Miner traverses the control flow graph and removes operations without a data relationship with the API. Lastly, the API path only keeps three types of program elements: APIs, condition checks, and return statements. API Miner uses the API names check and return to label the nodes. As a result, API Miner generates path for each API usage. After that, API Miner will extract the frequent subgraphs as API path pattern from the API path. However, there are two challenges. The The first challenge is that frequent subgraphs may be unconnected while the API path pattern should be connected. Assuming A, B, and E are frequent nodes where C is infrequent. Therefore, C and the edges related to C are removed during the frequent subgraph mining. As a result, the extracted API path pattern is unconnected. To address the problem, API Miner uses topologization and completion techniques to convert API path from general digraphs into complete topologies. For example, there's a loop BD in the API path. API Miner first unrolls the loop only once. Then API Miner adds assisted edges from each node to its descendants, which are shown as dotted lines. After that, API Miner aggregates the two paths into one complete topology. Therefore, the newly added edges can connect the frequent nodes and help extract the connected API path patterns. The second challenge is that frequent subgraph mining is an exponentially complex process that does not apply to large software. To address this problem, we first build the index matrices to improve the efficiency. As mentioned, API Miner labels the nodes by API names, check, and return. Then API Miner can label the edges by their head and tail nodes. After the alignment, each graph can be seen as a set of edges. After that, API Miner builds the lexicons of API path and edges. It traverses all the API path and uses 0, 1 to indicate whether the edge exists in the API path. Each column represents a forward index, and each row represents an inverted index. As a result, we can use the binary arithmetic to accomplish the graph operations. A trivial method for extracting frequent subgraphs is to check every subgraph. However, each graph has an exponential number of subgraphs. For example, an n-node graph has 2 to the nth power subgraphs. Therefore, directly generating all the subgraphs and counting the frequency is unsuitable for large software. To address the problem, our frequent subgraph mining algorithm is based on a priori. For example, suppose the frequency threshold is 2, meaning it is a frequent subgraph if at least 2 graphs contain it. E1 is frequent. E2 is frequent. E3 is infrequent. E4 is infrequent. E1, E2 is frequent. According to the a priori, we only generate 2 edge candidates from frequent 1-edge subgraphs, since subgraphs of frequent graphs must be frequent. As a result, we only generate 5 candidates rather than the previous 15. The last step is to detect API misuses. Benefiting from the index matrix, API Miner can use the binary arithmetic discriminant G and P equals P to realize the subgraph matching and check the violations efficiently. G means the API path and P means the API path pattern. We can find that G1, G3, and G4 can satisfy the discriminant. However, G2 does not. So we report the G2 as a potential bug. Finally, these are the evaluation results. The experiments were performed on a virtual machine with 48 cores and 128 GB RAM. Moreover, we compiled the software using LLVM10. We have evaluated API Miner with Linux kernel, OpenSSL, FFmpeg, and Apache HTTPD, which have a great quantity of code and ongoing maintenance. Our tool found 157 new bugs and gained 19 CVEs. These are the comparison results between our tools and the other state-of-the-art tools. We extracted the top 10 violated API patterns and the top 5 violations of each patterns as the test cases from API Miner, Crix, and API Sign. The figure is about API patterns. It shows that our tool can find the most true patterns. And this is about API misuses. Our tool can also find the most true positives. Apart from that, our tool has some limitations that need to be solved in the future. Violating API patterns will cause API misuses and lead to various security issues. This paper presents API Miner, a general framework that uses the frequent subgraph mining technique to automatically extract API path patterns to detect API misuses without predefined templates. We have evaluated API Miner with 4 widely used open source software. It extracted 4,788 API path patterns. Moreover, it detected 157 bugs and scanned 19 CVEs. That's all, thank you.